Well, thanks for coming. Thanks to the Institute of Astronomy for inviting me. Thanks to Matt. So as Matt says, I am not an astronomer. I'm a historian, and my specialist area of research for the last nearly 10 years has been the history of life on Mars. And so often when I say this to people, the first thing that people engage me in conversation about is this episode. And this episode is actually the end of my story. So I'm starting at the end. So many of you may already recognize what this episode is. That's Orson Welles on the left. As a 23-year-old, a precocious 23-year-old actor, him and the Mercury Theatre put on a radio production on Halloween 1938 of H.G. Wells' The War of the Worlds. But they framed the radio broadcast as if it was a live news broadcast from the site of Martian attack. At the start of the broadcast, they made it very clear that this was a dramatization. However, for people who tuned into the program late, what they heard appeared to be a news reporter panicked, reporting that Martians had landed in New Jersey and were vaporizing people with a heat ray. And as you see from these news reports, there was reported widespread panic. Allegedly, the police actually tried to break into the radio studio and force them off the air during the broadcast. This is normally talked about for two reasons. One, obviously, is to talk about the genius of Orson Welles, and the other is to talk about the power of radio in a new age of radio, to cause such a panic. But there's a third really important factor to this, which is what I want to talk about tonight, which is the idea that a large number of people could listen to the radio and think very seriously that Martians had just landed and started killing people. So what I want to do is go back. I'm going to start us more or less a century earlier and move through up to this point and hopefully make a case for why it's actually perfectly reasonable for people to have panicked in the way that they did, at least some people. So a good place to start in the 19th century is in the middle of the century, and looking at a heated debate that erupted about whether or not extraterrestrial life existed. By the first half of the 19th century, there had been centuries of debate about the possibility of extraterrestrial life. By the early 19th century, things had really come to a head in the sense that quite a lot of people, some have argued maybe the majority of people, were starting to think that extraterrestrial life probably did exist throughout the universe. And this was based really on two principles which combine astronomy and theology. One has come to be known as the Copernican principle, which is basically a principle that humans aren't special or unique. Called the Copernican principle, of course, because it was Copernicus who removed the Earth from the center of the universe and actually pointed out that we just happen to be one planet amongst many orbiting a fairly unremarkable star. And then there was a theological argument for plenitude. This was an argument, effectively, that it would seem somewhat obtuse for God to have created a huge universe and then have put life, which seemed to be the purpose of the universe, on one fairly unremarkable planet. This comes to a head in this debate, this argument between these two men. On the left, William Whewell, who published the book anonymously in 1853, arguing against extraterrestrial life. Whewell was a liberal Anglican. He was master of Trinity College, Cambridge, and his basic argument was really based on scripture. He said, okay, whatever, plenitude, Copernican theory, whatever. The important thing is, if you read the Bible, it doesn't say anything about aliens. Brewster is a Scottish evangelical, and a year later publishes a counterblast, an attack on Whewell. And Brewster really argues from the point of view of plenitude. Brewster really argues, if you look at his title, More Worlds Than One, the Creed of the Philosopher and the Hope of the Christian. And he basically says, really, it's an insult to God to argue that you create all of these seemingly millions of stars, and you've only put life in one spot. One important thing to point out at this point is that if you look at the responses to these two books, about 2/3 of those responses back Brewster. Now that's not a concrete argument, that's just counting some articles, but it does make the point that probably the argument for extraterrestrial life was more popular than the argument against. This is all very well and good, you might say, but what do astronomers have to say about this? The answer is that to a lot of astronomers, they didn't have much to say at all. And I pick out here, I always pick out poor old Benjamin Apthorpe Gould to pick on here. This is a good quote from him from 1859 about what astronomy is and what astronomy is not. The science of astronomy consists in the investigation of those laws which govern the motion of the heavenly bodies. The natural history of the heavens, although a cognate and most interesting field of inquiry, is not included in the domain of astronomy proper. So this is the kind of thing that Gould would do. He would sit underneath what's called a transit instrument, and he would record the positions of the stars in the night sky very precisely. And that form of astronomy, what we tend to now call positional astronomy, was the principal concern of salaried astronomers in national and state institutions, university institutions, but also places like Greenwich. And that's because that kind of astronomy is what you need for timekeeping, and it's what you need for navigation. If you want to solve the problem of longitude at sea, for example, if you want to navigate at sea, you need astronomical tables. And it's the astronomer's job to make them. It is not the astronomer's job to speculate about whether or not there are aliens on other planets or on other orbiting other stars. The deadlock to this argument, remarkably unfortunately for Benjamin Apthorpe Gould, comes in the same year as he made this quote. 1859 is the year of the single most important scientific discovery since the Copernican revolution. I'm sure you all know what it is. Darwin. Darwin's a biologist. No, it's got nothing to do with Darwin. It's spectroscopy, astrospectroscopy. The single most important scientific discovery of the 19th century. Why? Because, as boring as astrospectroscopy sounds, astrospectroscopy is the first scientific evidence we have for a problem that was crucial for Whewell and his argument against extraterrestrial life. One of the things Whewell said in his book is, well, look, it's all well and good saying that the universe is plentiful, there's life everywhere, but we don't actually know that there is any material substance in the rest of the universe. He says all we can see are some dots of light and a few planets. Maybe the planets have got some substance to them, but we don't know that there are any planets around any of these dots of light we can see. And it could be that the rest of the universe has no substance to it whatsoever. It's not made of the same stuff as our solar system. And this is what spectroscopy spectacularly disproves. What spectroscopy shows is that the whole universe is made of the same stuff as our solar system. So what you have with spectroscopy is two German chemists/physicists, Robert Bunsen and Gustav Kirchhoff, demonstrate that when you make a completely pure chemical element glow, it emits in its spectrum of light. If you take the light from that glowing element and you use prisms to break it up into its spectrum, same way that you do with a prism, you get the full rainbow of light. If you have a completely pure element and you make it glow, instead of getting this nice rainbow of light, you get these particular bands. And those particular bands exist on a scale at very particular points. So they're like a fingerprint for chemical elements. And further, what you find is that if you make light pass through a gas that contains those elements, the reverse happens. You get dark bands where the light that's passing through, say it's passing through an element that has sodium in it. This is your sodium line here. Up here, there's a dark band. What that means is that this continuous light, this is white light, the spectrum of white light, the continuous light, but what's happened is that clearly it's passed through something with sodium in it. because the sodium has been absorbed at that point in the spectrum. And this is sunlight at the top here. And what you suddenly see is you're like, ah, well, light that's come out of the sun, from the center of the sun, has passed through the sun's, the gases in the sun, so there must be sodium in the sun. Truly extraordinary discovery. Truly, truly extraordinary discovery, because then you can turn the spectroscope, you can attach one to a telescope, and you can do this, you can find this. It is remarkable that the elements most widely diffused through the host of stars are some of those most closely connected with the constitution of living organisms of our globe, including hydrogen, sodium, magnesium, and iron. On the whole, we believe that the foregoing spectrum observations on the stars contribute something towards an experimental basis on which a conclusion, hitherto but a pure speculation, may rest, viz. That at least the brighter stars are, like our sun, upholding and energizing centers of systems of worlds adapted to be the abode of living beings. William Huggins was the most famous and decorated astrospectroscopist of his day. So you can see this is being published in the Philosophical Transactions of the Royal Society. The spectroscope destroys Whewell's argument. The whole universe is full of all of these exciting chemical elements. And Huggins soon finds, for example, he reports that he's detected water on Mars. Now, I should add a caveat here. Historians don't like to do this because we don't like to give winners and losers, but I have to admit, footnote, we now know that those results were very optimistic. He hadn't actually really detected water on Mars. The problem was that, of course, light coming from Mars comes through the Earth's atmosphere. So you have to disambiguate the classic scientific problem of signal and noise. And so he was looking at the moon, which we know doesn't have an atmosphere, and then looking at Mars and seeing if there was any difference. And he said there was. The important point here is that immediately, not only do we have an argument for extraterrestrial life, but we've also got an argument saying there's water on Mars. And here's where I admit that Charles Darwin is important. Because, and this really is something I think that people don't think about when they think about Darwin. One of the important points that Darwinian evolution allows is the development of all kinds of forms of life. Because Darwin's system allows for many divergent forms of a life to evolve over extremely long periods of time. And all you need are the recipes for life. And so when you combine the spectroscope with Darwin, you've really got a pretty robust argument for the development of extraterrestrial life. And that, for example, is what this man thought. This man is one of the most famous astronomers of the late 19th century. He's a rather neglected character in the history because he tends to be treated more as a writer than an astronomer. But most people in Britain, if you stopped someone in London, in the streets of London in the 1880s and asked them to name an astronomer, most likely they would name Richard Proctor. And what Proctor says is, this is his kind of bon mot argument for extraterrestrial life. Until it has been demonstrated that no form of life can exist upon a planet, the presumption must be that the planet is inhabited. So he's kind of inverted the argumentative direction. Instead of having to prove from first principles or from some theological argument, he said, well, hold on, what we've got all of the building blocks for life, we've got time, we've got chemical elements, and we've got the case of Earth, and we know that you end up with humans running around. So we should presume that there's life. Now, I should add, this is not uncontroversial. Certain more skeptical or more conservative scientists write scathing reviews of Proctor saying that this is too far in terms of speculation. One of the reasons they do that is that Proctor's books are spectacularly successful. They sell in thousands and thousands of copies, go through many, many print runs. And his book, which I've taken this from Other Worlds and Ours, as you can tell, is a book specifically about the possibility of life on other planets. And Mars is obviously a crucial object for this debate. This is Proctor's new map of Mars, which he develops at the end of the 1860s, based on new observations of the planet. It's at this point that I should pause just to reiterate how difficult it was to actually observe, to actually look at Mars in the late 19th century. Well, the first thing to point out is that Mars only occasionally comes on into what's called opposition, a close approach to Earth. Most of the time, Earth and Mars's orbits are such that we're really far apart. But once about every 2 years, our orbits pass such that we're in what's called opposition. We've got the Sun here, and we're kind of lined up, and that's when Mars is closest in observation. So about once every 2 years, you can observe Mars well, visually, for a couple of weeks. And the quality of those oppositions vary. The really good ones, perihelic oppositions, only happen once every 17 years. So that's one thing. Mars is hard to observe because you just can't look at it that. The other thing is that even with a really powerful telescope, it's tiny. So if we were to go out tonight during a perihelic opposition in the best possible conditions, and we climbed underneath the Northumberland telescope here, which I hope many of you have looked through. That's a massive telescope, right? That's a huge telescope. The best possible conditions, Mars would be in the eyepiece roughly the same size as the Moon is to the naked eye. So the very best conditions once every couple of years is that you can go out into your garden and look at the Moon. And imagine then how much you would know about the Moon and the composition of the Moon and what the Moon looked like. That's the problem people faced with Mars. This is the map that Proctor comes up with. And one of the things that you may have noticed about this map is that Mars looks somewhat like the Earth. You have the Herschel continent, and then you have these seas. Got the Hook Sea. Proctor got into lots of trouble because he named all of his continents and seas after British astronomers. So the French got really upset. And this is what he says. Throughout the whole of the solar system, there is no object which affords so many points of resemblance to our own Earth, or exhibits so clearly the signs of adaptation to the wants of living creatures as Mars. It presents a scene which requires no very lively exercise of the imagination to dot with villages, towns, and cities peopled with busy workers. So at this point I want to point out two things that seem to be happening here, which I want you to hold in your head as I go through and start talking about how some of this gets cashed out in wider cultural debates. And the first is that use of analogy is really important here for talking about Mars and for talking about extraterrestrials generally. And this is always something that is unavoidable. One of the obvious problems with talk about extraterrestrial life for astronomers is that oftentimes we have one data point. And that's us, that's Earth. That's a good data point. It's a very well-studied data point, but it's still only one data point. And so often you have to just use analogy. You have to make an analogy between the Earth and whatever object you want to study in terms of whether it might have life on it. So the analogy here is strong between Earth and Mars. And Proctor specifically calls Mars the twin of the Earth. So the analogy is very strong. The other thing, which is a bit more conceptual and which you're going to have to come with me on this is part of my broader argument. This is the kind of thing that I wrote in my PhD, so it's a bit hand-wavy and academic. But it's this idea that Mars is a screen onto which humans start projecting ideas about the Earth. I'm going to make the case for that more strongly in a minute, and I'm going to give you what I think is some evidence points for that. But I just want to put that out there. This idea that Mars might potentially be an object through which we can actually think and argue about issues on Earth. One of the reasons for that is because Mars, rather handily, as far as people in the late 19th century were concerned, was an older planet than Earth. And the reason is this. This is called the nebula hypothesis. This was the dominant idea, the dominant theory for how the solar system formed in the period that we're talking about. And that is simply that it started as a fairly inchoate ball of gas and matter, and it started condensing, and as it condenses, it starts swirling, and then it condenses, and it forms into our solar system, ultimately forming with the sun at the center. And what that means is that the planets form from the outside in. So Mars is older than the Earth. It's also smaller. But if you're a new extraterrestrial evolutionist, as Richard Proctor and many others are, it's an interesting point, right? Because it means that Mars, if it does have evolved life, quite possibly has more evolved life. Life that is more evolved than on Earth, because it's older. If it's the twin of the Earth, but it's older, then in certain respects, it might actually represent the future of the Earth. This becomes particularly interesting for people from 1877, which is the year that Mars comes into perihelic opposition, and Giovanni Schiaparelli in Milan observes Mars and produces a new map that feature these things. Straight, narrow bodies of water. And these he calls canali, canals, or channel. So what we get quite quickly after 1877 is an extended debate about what exactly people are seeing on the surface of Mars with these straight dark lines. After Schiaparelli has seen them, lots of other astronomers start seeing them and start reporting them. But what happens is that you start getting a lot more of them. And the big bodies of water start disappearing, and you start ending up mostly with very straight, very dark bands of canals. And so this is what Camille Flammarion, the great French astronomer, says. Mars is sectioned by a geometric network of straight lines crossing each other at angles. From this, what can we infer? Well, Flammarion jumps straight to the point. The habitation of Mars by a race superior to ours seems very probable. And this is what Richard Proctor, our old friend Richard Proctor, writes to the Times in 1882. This is when there's lots of news about Schiaparelli's canals, and so Proctor writes a letter to the Times, and he says, should it be proved that the network of dark streaks has a real existence, we should by no means be forced to believe that Mars is a planet unlike our Earth, but we might perhaps infer that engineering works of a much greater scale than any which exist on our globe have been carried on upon the surface of Mars. The smaller force of Martian gravity would suggest that such works could be much more easily conducted on Mars, as I have elsewhere shown. It would be rash, however, at present to speculate in this way. Which I think is really wonderful. If you ever want to write a letter to the newspaper, I recommend this form. Make a really outlandish claim, and then at the bottom say, however, it would be really rash to make this claim. So, very clearly what we're seeing here is the suggestion that these canals might be engineering works. They might actually be constructed by Martians who potentially are more evolved than humans, and who potentially might actually be trying to communicate with us. At about the same time that this happens, well, a bit later in the early 1890s, there becomes a big debate about whether or not astronomers have seen light flashes on Mars, and whether this might be Martians attempting to communicate. And I mention this in part because it would be unfair of me to represent all of this as if this is all going on and no one's complaining that this is all a bit rash. So this is J. Norman Lockyer, the founder of the editor of the journal Nature, at the same time that this news of signalling is going on, complaining in his own journal. The widespread notion of signals from Mars rests only on a mistranslation and upon the popular imagination running riot among the startling revelations of modern observers. So the mistranslation claim is simply that Italians don't have separate words for canal and channel. In English, canal always means artificially made, channel always means natural made. In Italian, you use the word canali for both, which is a wonderful ambiguity at the heart of Schiaparelli's findings. And Schiaparelli reveled in it. People would ask him, are these made by Martians? And he said, it's not impossible. So there are astronomers already getting pretty upset at this. So one of the obvious things that we can point out at this juncture is that H.G. Wells's novel, The War of the Worlds, needs to be read in the context of the debates I've just described. So Wells's novel is published in serialized form at the end of 1897. So Wells is writing it in the mid-1890s, amid this huge debate over whether or not Mars might have canals on it, whether there might be intelligent Martians, whether these Martians might be incredible engineers. And bear in mind that H.G. Wells not only had scientific training, but H.G. Wells also was a journalist. He was a science journalist, and he actually wrote anonymous pieces about what life on Mars might look like. So his novel is much more than just a fantasy. It's always taken as one of the first pieces of science fiction, but I don't think Wells would really have appreciated that title, that moniker. He called them scientific romances. He thought that fiction was a nice way to play with new scientific ideas that were at the frontier of what is or isn't known. And I hope that this quote gives you a good sense of how imbued his novel is with these latest findings of astronomers. Since Mars is older than our Earth, with scarcely a quarter of the superficial area and remoter from the Sun, it necessarily follows that it is not only more distant from time's beginning, but nearer its end. The secular cooling that must someday overtake our planet has already gone far indeed with our neighbour. Its air is much more attenuated than ours. Its oceans have shrunk until they cover but a third of its surface. That last stage of exhaustion, which to us is still incredibly remote, has become a present-day problem for the inhabitants of Mars. The immediate pressure of necessity has brightened their intellects, enlarged their powers, and hardened their hearts. And looking across space with instruments and intelligences such as we have scarcely dreamed of, they see a morning star of hope, our own warmer planet, green and with vegetation and grey with water, with a cloudy atmosphere, eloquent of fertility. So one of the Darwinian points that Wells is making here is that as a critique, it's suggesting that if Mars has life that's more evolved, it won't necessarily be more humane, won't necessarily be nicer. And in fact, he sends his Martians to come and drink our blood and destroy us with heat rays. Where might he get such an idea of desperate Martians, Martians that desperately might want to come to Earth and start stealing our blood and our water? Well, he happened to have been friends with the man who made this beautiful globe, Percival Lowell. I should say the globe wasn't made by Lowell, the map on which the globe is based was made by Lowell. Percival Lowell was an American astronomer from an aristocratic family. He became obsessed with Mars. He built his own observatory. He equipped it with a huge telescope. And he became the great proponent for the idea of canals on Mars. And in his rendering of Mars, the planet is actually really on the precipice of death. There's almost no water. This is vegetation, not water. The only water on the planet is trapped in its polar caps. And so the Martians have come up with an ingenious solution, a network of canals that are really canals in that they are man-made waterways and they are used for channeling the meltwater from the polar caps to the warmer equatorial regions where the Martians live and grow their crops. And so what you're seeing in the dark lines is not the water itself, it's the crops that the Martians are growing next to the water. So Lowell has developed a complete planetary theory that takes into account not just astronomy, what we're seeing, and he argued vociferously that this is what he saw. This was not a fantasy, he wasn't making this up. He argued that at the eyepiece, one saw these straight canals. But it's also involving biology, evolutionary ideas, and it's also involving ecology. The idea of the ecosystem of a planet like Mars. And that form of ecology worked both ways, right? It was again an analogy between Earth and Mars. Lowell has this wonderful phrase, we know how other bodies look to us, but we ignore how we look to them. It is not so easy to see ourselves as others see us. This wonderful picture, which he puts in his book, that's Hyde Park as he took a picture of it from a hot air balloon. On our own world, we are able only to study our present and our past. In Mars, we are able to glimpse in some sort our future. So the question then becomes, what is happening here on Mars? Why is this the kind of theory, the kind of idea that might have valency in the late 19th century? Where is Lowell arriving at this idea of industrious Martians and this idea of a dying planet? Well, as a historian, it behoves me to argue for a more contextual account than simply Lowell looked through his telescope and saw this. And one of the things that I think is going on is a reflection on ecological decay on Earth. And the site of ecological catastrophe in the late 19th century is India. Under British Raj rule between 1877 and 1902, somewhere between 12 and 29 million people starved to death. And this is a human catastrophe, and it is a political controversy for the Raj, for the British governance of India. And this question centers around whether famine in India is a natural ecological phenomena or whether there is political blame on the British. And it behoves me to quote my colleague Mike Davis here, who studied these events in telescopic detail. And his argument is very simply that modern assessment is damning of British governance of famine in India. Britain instituted a form of global grain exchange through India. It used India as a plantation for grain. During the 1877 famine, for example, grain exports from India went up fivefold because the price of grain shot through the roof. And therefore, I would not argue that the famines in India are ecological. However, someone like Lowell probably would have. And that's because Lowell very much ascribed to an idea of natural ecological decay. And he writes about this at great length in his books. What he's suggesting on Mars is that the death of Mars is coming to Earth, and that we're starting to see it in places like India, and eventually it will come to all of us. The Caspian Sea is disappearing before our eyes as there remains some distance from its edge of what were once ports. The Earth then is going the way of Mars. Deserts represent the general unspeakable death grip on our world. They mark the beginning of the end. This, however, is not a depressing story for Lowell. And there's a reason for that, and that's that he is a well-fed capitalist in the northeast United States who has a huge amount of money from industrial concerns, and as a result, he's extremely optimistic about the effects of and the ameliorating power of technology to overcome these ecological concerns. So his irrigation system on Mars is, I think, very much a reflection of what people like Lowell felt were the great achievements of canal building on Earth at the time. So the Suez Canal, of course, built in the 1860s, and at the time that Lowell was writing, the Panama Canal was very much kind of near its completion. And obviously there's a Darwinian lesson in here for Lowell, but it's a positive Darwinian lesson. Increasing intelligence would cause one species to prevail over its environment. This species will thus become lord of the planet and spread completely over its face. So the Martians have succeeded. They've defeated ecological decay by being good technologists, building wonderful canals across the planet. And this, of course, is reflected in the news in the positive way in which Mars is portrayed. So we have here, Martians build 2 immense canals in 2 years. This is a wonderful quote from the Brooklyn Daily Eagle. And so the Lowellites reason, necessity being the mother of invention, the Martians dug the huge canals. If there are powerful telescopes on Mars, they're smiling frequently perhaps over all the fuss and bother this country is making in digging, in their eyes, a mere little trench across the Isthmus of Panama. And as our technologies got better, so the Martian technologies get better. And this is where we get back to our radio broadcast. I'm bringing up here an example a decade before the radio broadcast, which was when, in the opposition of 1924, the Secretary of the Navy in Washington, D.C. orders the signal stations of the Navy to listen out for radio transmissions from Mars. At this point, by the 1920s, the novel technology isn't canals, the novel technology is radio. And so the Martians are now trying to signal us by radio. And this is what happens. Weird radio signal films deepen mystery of Mars. David Todd of Amherst College uses a new recording system to record radio signals that he argues come from Mars. And he says that one of the things you see in them is the shape of a face in the transmission, which leads to my absolute favorite letter to an editor ever. This is a letter to the Christian Science Monitor. Possibly there is nothing left of the inhabitants of Mars except heads. So it's this idea of the Martian, with their radio and their massively evolved heads, that people are reading about in the newspapers through the first half of the 20th century. And it's this vision, this idea of Mars, that is what people carry with them when they turn on their radio and listen to Orson Welles. I hope I've persuaded you. Thank you very much.